The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? You can all use the questions tab to give me a quick confirmation, guys, if you all can see my screen and hear me loud and clear as well. Perfect. Thank you for confirmation, everyone. So before we get started, let me quickly introduce myself to you all first. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 13 years now, where I have been leading the global design and development teams for designing enterprise solutions for different industry verticals, including insurance, retail, banking, pharmaceutical, aviation, and location-based services. And mostly I've been active in the markets of India, US, Canada, Singapore, Australia, and other Southeast Asian markets so far. And in terms of the training front, I have been working as a corporate trainer as well since last 5 years, where I have been training the workforce of companies including Accenture, Mercedes, EY, Capgemini, Adobe, Credit Suisse, NIT, Grab, among others, in training them on different technologies, specifically in cloud computing, on AIML, and big data engineering technologies. So that's in a nutshell of what I've been doing for more than 13 years now. So before we get started, let me quickly guide you on the most one of the most common few pointers. So the first, we can say a few guidelines, and if you follow these guidelines, then we'll be having a really smooth journey going forward. So first of all, we'll be maintaining a fixed pattern of delivery. That means we'll be talking about the topic continuously for, let's say, for 15-20 minutes, and then we'll be having a continuous discussion on the topic itself for 5-20 minutes, and again a continuous discussion on topic for 15 minutes, again a quick question answer round for 5 minutes, and so on.
so that we can maintain a good balance between taking up the questions and also talking about the topic that we have to cover as a part of the session. Second pointer, since we have good number of participants joining in, so we have kept everyone on mute by default. So in case you have any questions that you need to ask and to get clarified, so please drop your questions directly in the questions tab, so that once I have seen a question, I can make sure to answer them one by one. And third pointer, since we have good number of participants joining in, so it's natural that sometimes some of your queries may not be answered. For example, sometimes some of your queries may be buried in the pile of questions that we are going to get. So in case that happens, and please do not feel disheartened and try to try to post your questions again and again in the same questions tab, so that once I have seen your questions, I can make sure to answer them one by one. All right. And fourth pointer, so kindly refrain from asking questions that is not a part of the ongoing topic. I repeat, kindly refrain from asking questions that is not a part of the ongoing topic. So, because if we do that, we will be creating confusion not only for us, but also for others as well, which we definitely do not want, right? So if you have something that has nothing to do with the ongoing topic, then please reserve those questions to be asked towards the end. And once I have seen your questions, I can make sure to answer them, answer your queries one by one. So are we all clear on these pointers? Please give me a quick information, everyone. Are we all clear on these pointers? Perfect. Thank you so much for the confirmation, everyone. And there are certain few common questions being asked by the participants as well, that yeah, that will we get the recordings of the session? Then yes, if you have that question, then yes, you will be getting the access to the recordings as well. So once we are done with the session, you will be getting the access to recordings directly in the LMS itself. And second most common asked question is, we don't have the access to the LMS. So in case you don't have the access to this LMS here, we can navigate to learning.educa.co and use the credentials given to you. In case you don't have the credentials yet, so you can ask the support team to give them to you as soon as possible. All right. Sure, Educa guest. We'll do that. So let's get started. So we are going to have our workshop divided in 2 different days. So that's why we have the content also divided in 2 days. That means we have the content for day 1 and then we have content for day 2. So today we are going to first of all set the base correct. That means we are going to discuss on the foundations of what exactly data science is, and again in terms of the EDA and different components that we are going to make use of when we start working on the actual analysis tomorrow. So again, in case you don't have the access to the LMS, guys, don't worry on that. So we have a separate dedicated focus team to help you out on that. So let's try to just focus on what exactly we have, what we are going to discuss here. And in case you are not having the access to LMS, codes, or recordings, for that we have a separate dedicated team to help you out. All right. So let's get started with the presentation first. So today there is little scope for having any hands-on because today we are going to discuss on the basics of what exactly data science and EDA concepts are, so that once we start working on the hands-on in our next session, we'll be having a complete clarity of what exactly we are doing. So the main problem statement that we are going to focus on, so we know that we are going to perform the analysis on PUBG. So Player Unknown Battleground, or known as PUBG, is basically an online multiplayer battle royale game developed and published by PUBG Corporation. So Battlegrounds is a player versus player shooter game in which up to 105 players fight in a battle royale game, and a type of last man standing deathmatch. So the main problem statement that we are going to focus on, so we are provided with large number of anonymized PUBG game statistics. So each row contains one player's post game statistics, and we have to create a model which predicts players finishing placement based on their final stats on a scale of 1 to 0, where if the value is closer to 1, then that is going to be considered closer to winning. If the value is closer to 0, then it is going to be considered to simply lose the game. And here we have to perform PUBG data analysis and perform the EDA on different questions. So first of all, we have to find out, does killing more people increases the chance of winning the game? If it does, then what exactly are the parameters which increases the chance of winning the game? And how does total distance traveled by the player impact the winning? And how do we catch fraudsters in the game? So we have multiple outliers. So how exactly we can catch those different fraudsters? That is what we are going to focus on as well. And then which features were most important in making this particular prediction? Which features were most important in making this prediction? That is also what we are going to focus on. So on day one, we are going to focus on exploring the career opportunities in data science and what exactly is a schedule for any data scientist. And then we are going to understand how we can pre-process data set. And then we are going to discuss on the concepts of the EDA, how exactly exploratory data analysis is useful and how. And then we are going to discuss on the concepts of how we can apply feature engineering to generate new features. And then we are going to discuss how exactly we can get the access to the data set from PUBG and how we can set it up on Google Colab for our analysis. So basically, if we talk about career opportunities in data science, then there are multiple roles available out there in the market right now. So we have positions such as data analysts, we have for data administrators, for ML engineers, ML as in machine learning engineers, then we have for data engineers, then we have position available for data scientists, and then towards the end we have data architects. So whatever we can see here in dark brown, so we can see these are mandatory skill sets to work in these different profiles. The ones in orange, they are again not at the same level as the mandatory one, but again they are preferred. And then whatever we can see here in yellow, they are optional. So for working as a data analyst, we need to know about programming, business intelligence, data wrangling. Data wrangling is, in simple layman terms, working on data pre-processing. So whenever we get the access to data, we have to pre-process. That means that data is dirty. That data contains multiple errors. That data contains multiple anomalies. We will be having multiple missing values, we'll be having multiple outliers, we'll be having multiple data inconsistency as well. So they are all have to be removed first, correct? And before we can, because we, before even we can think of working on creating any model, we have to make sure that data should be clean for us to analyze. Because if data is not clean, then we will not be able to get the accuracy that we are looking for, correct? And that's why we have to work on improvising the data accuracy by data wrangling method, as in data pre-processing. Then we have to focus on data administrator. So again, when we talk about data administrator, he or she is the one who is responsible for programming, for database management and data wrangling, as a part of the someone who is responsible for management of data coming in from different sources. Now, being the machine learning engineer, we should be proficient in almost everything, but not that much in database management, on the cloud services, and also in big data. Because database management is something taken care by data administrator itself, so we don't have to worry much about that. Then working in as a part of BI developer. BI developer means BI means business intelligence. So we working as a BI developer means we should be having a good insight on BI, as in business intelligence tools. Like we have Power BI, we have Power BI, then we have Tableau servers. So again, these all are the platform that we should be good with, and we have to make sure that we are having a good access to all of these different platforms, a good access and good knowledge on these platforms to proceed further. All right. Next, we have data wrangling can be removed by pandas by dropping, which removes empty space. Not just data wrangling doesn't mean only empty space. It means working on removing outliers, all the inconsistencies that we may have in data sets, right? So obviously, yes, we are going to first of all process that. We have to find out that what exactly is the incorrect value, and then we have to process it by using different available libraries. All right. And how exactly it is done? That is what we are going to focus on as we proceed further. Is it clear now? Edurka guest? Perfect. Thank you for confirmation. And then working as data scientists, we have to be proficient in almost everything from programming, business intelligence, database management, on statistics, on data wrangling, machine learning, and on deep learning, including mathematics, because without that, we won't be able to apply the logic. And then we should be good enough to work on the cloud, on big data components one by one. All right, so now the most common myth, let's bust some myths. So AI versus ML versus DL versus DS. So AI means artificial intelligence, ML means machine learning, DL means deep learning, and DS means data science. So if you talk about the AI, the area of computer science that emphasizes on the creation of intelligent machines that work and react like humans. So it's like a superset of machine learning and other components. So machine learning is basically used for training any given system. So just to see as a simple example, now we are able to walk. How? Because we have been trained how to walk, correct? We have the now babies always have the capability of walking, but again, until and unless they are trained on how to walk, how to run, they won't be able to walk for the entire life, correct? So that is something that has to be trained. Same way, we know how to speak because our parent they taught us how to speak, correct? If they didn't teach us how to speak, then we will not be able to speak for a lifetime. Although our brain is capable of working for we can say of us fully functional for handling any kind of voice-based commands here, and again to handle the speech. But if we are not trained, then even the AI is not going to work, correct? Same thing is applicable for systems. We have to define the model, but without training the system, okay, how exactly things should be, it is going to be of no use. Then we have deep learning. So deep learning is basically the subset of machine learning, which simply concerns with the algorithm inspired by structure. Now, basically, machine learning is limited, and again, just to make sure that again systems they mimic the human brain behavior. For example, if we are training any system to identify okay what exactly one is, so now some people they may write one as this one, some people they may write one as this one, some may write this one as this one as well, some may write one as this one, correct? So although they all mean one, but there are different ways people write one based on their preferences, correct? So a human brain can automatically recognize okay that these are what, these are numbers, but the traditional machine learning system they cannot, correct? So that is why we use something called as deep learning to make sure that we are able to use the same perceptron that we have in our brain, the same method to identify different patterns, spatially useful for the image and video processing. And then data science is basically not exactly a subset of ML, but it uses machine learning and the deep learning concepts to get insight from both structured and unstructured data sets. That's how it is going to be defined. Next, in terms of data scientist life, so who exactly is a data scientist? They are part analyst and a part artist. So they use the technical and the analytical skills to extract insights out of the given data set. So basically, they are capable in Python, R. So Python is one of the most widely used languages in terms of data science, and then R. R is basically used for statistical analysis. And then we have predictive modeling here. So again, we have now data scientists, they have to be proficient in terms of statistical analysis, in terms of predictive modeling, in terms of machine learning and natural language processing. So they also have to be well aware of how exactly deep learning model works, how data warehousing works for storing data set coming from different sources, and how the components of big data is structured so that they can take advantage of distributed file system and a real-time stream processing. And then they should be aware on the cloud services, because we know at the end every solution is being deployed on cloud nowadays. And what exactly they do, so they collect data and analyze it from different angles. They are responsible for cleaning existing raw data and build perspective models out of it. When we say cleaning, it simply involves data wrangling methods like we had discussed. So data wrangling ensures that we are able to remove all the anomalies, inconsistencies from the given data set to work on a better model creation. And then they have to identify correct business models and problems, and again, simply give solutions to work with them. And then how do they help organization? By focusing on cost optimization, by making sure that they are able to develop strategies which can help the companies in getting the best possible insight from it, and then also helping the companies to improve the operational frequency, or say efficiency, and then reducing the risk involved with any decision making process, and then building the recommendations engine that is followed by YouTube, by Netflix, and all the other content streamers, and then how to increase the data accuracy so that we don't have to work on creating a wrong model. It has to be improvised. All right, so let's proceed further. So why exactly we need data science? So what happens in an internet minute? Now this is a fact that almost in every minute we Twitter gets almost 1 million tweets. So again, these again different tweets are from the global users. YouTube gets almost 400 hours of content being uploaded. Amazon receives almost $500,000 of orders. Same way for Facebook, it generates around 1 terabytes of data. And Apple sees almost 108,000 application downloads. Android gets almost 211,000 app downloads. LinkedIn gets almost 3,000, 31,000 user searches. And then Instagram sees almost 3.1 million likes happening in every minute. And again, same way for WhatsApp, for Netflix, for Pandora, for Snapchat. Now, the main gist of this infographic is that data is currently being generated, and that too at a simple alarming scale, right? And we have to ensure that we are able to consume the data in the most efficient way possible, and that too as quickly as possible, which is currently being generated at the given pace. All right. So if you talk about different varieties of data, so they are data in different formats. We have structured and then we have unstructured data. So structured data can be displayed in rows, columns, and relational databases. As numbers, dates, now it involves numbers, dates, and strings. So they almost 20% of enterprise data, they are in the structured format. Like we have a normal tables, we have the relational databases, which requires less space and they are easier to manage as well. Whereas 80% of data is highly unstructured, which involves multiple JSON records, XML records here, images, videos, audio clips, again, all the emails, the spreadsheets. Okay, they all are a part of unstructured data sets. And since they are almost 80% of the amount of data being generated, that's why they are really difficult to process. And plus, they are not in the tabular format, right? So it's not easier to simply store them in a given database and that too by using a given schema. That is not possible at all. And that has to be managed by using an efficient system. So how to make sense out of data? So data is always scattered. Data here is always scattered. So we have to make sure that we create patterns. And again, we make sure that the same set of data should be grouped together for a better analysis. And then we also have to make sure that by using analytics, we give a proper shape. That means we make sense out of the data that we can use it for taking a better decisions. So now the question comes, how exactly to make sense of data? So it involves in the process, it starts with the process of data collection. So in terms of data collection, we have to make sure data is collected from different sources. For example, we may have data in different data sources. For example, we may have data in databases, in Excel, in normal Excel or CSV files. We may have data in different ERP solutions and different CRM solutions. So we have to make sure that we do collect data from these different data sources, and then we store them in a centralized place as a part of data warehousing. Then we have data pre-processing. So we have to make sure that data pre-processing is what? Working on removing all the anomalies in a given data set. So we have to remove all the anomalies, and we have to remove all the inconsistency in the given data set. All the outliers should be processed, and how they are processed, that is what we are going to focus on as a part of our today's journey in terms of performing the EDA as an exploratory data analysis. All right. And unstructured data can be done. Now we cannot convert every data into unstructured to structured format. Like we have multimedia elements, so we have to make sure that we use the best way possible to store the data to reduce the amount of data sets here. And that is what we are going to focus on as we proceed further into our session. All right. So is it clear now, Edric August? And then we have data transformation. So let's say if we have 10 different rows and now we have to remove certain rows, then that means where we are going to transform the existing data set. That means if we have to move some rows and we have IDs in the given data set. We have, let's say we have a column known as ID. We may have a column such as name. Now for our data processing part, that is not required. That is not required. So in that case, we can simply go ahead and drop the entire columns, because in case we maintain the unwanted columns in the given database, and that is going to increase the weight of data, increase the amount of size acquired by the data. So that is something that we don't want, correct? So in that case, we can eliminate that. And then we have feature engineering. So let's understand what exactly we mean by feature engineering and data pre-processing. In simple layman terms, let's open up our Excel sheet. So we can understand why exactly we need data processing, data pre-processing, and data engineering part. Let's open a simple blank sheet. Suppose here we have product. Also here we have product ID. We have product. We have total quantity ordered. We have total amount paid. And then we have ratings. We have product ID, then we have product name. We can name it as product name. All right, we have total quantity ordered, then we have total amount paid, and then we have the ratings. All right, so now let's add some data here in these different columns. First of all, we have ID. We have 101, we have 102, 103, 104, 105, and so on. Name is what we have A. We have A, and we have B, C, D, E, F. It can be multiple names here. Then in terms of total quantity ordered, we have quantities such as, suppose we have 32, then we have 40, then we have 5,000, then we have 36, then we have -2. In terms of total amount paid, we have 320. Here we have, suppose, 400. Then here we may have, suppose, -560. Here we have a missing value. Then here we have, suppose, 100. In terms of rating, we have 4.2. Here we have C. We have 3.6. We have we have suppose A, and then we have missing value. Can we use this data for model creation? Anyone? Can we use this data directly for our model creation for further processing? Everyone? Absolutely not. So we cannot directly use it, correct? So this data requires a lot of work because there are multiple anomalies in the given data set. So first of all, we have this product ID. So will this column help us? Will this or this two columns, will these columns help us in any way in our data analysis? Everyone? First of all, these two columns, product ID and then we have name. So will these two different columns help us in our data analysis of any kind? Data analysis? In terms of model creation, in terms of now they are name, they are not category. For example, if there was a category, then yes, that would have been helpful. If there was a specific feature in that particular product, then yes, that would have been helpful. But again, having the name and the ID, they have no value in terms of the data analysis, correct? Because they are going to be unique. They are going to be different for different entries, correct? So in terms of data values, in terms of data analysis, these two columns are of no use, correct? So as a part of data processing first, what we are going to do, we are simply going to delete these two columns because if we have, let's say, 100,000 records in terms of different, we can see different rows, and if we keep these two columns with us, and we are simply increasing the weight of our data unnecessarily, correct? So if you don't need something, then it's better to simply delete that part off to avoid adding extra weightage to the code. All right. Then we have total quantity ordered. So we have 32, for example, for now, we can keep them. Then we have, we can see three of all the values, they are close to value 30 and 40, correct? But again, this is 50,000. So this is most likely to be an outlier. So outlier is what? Having abnormal values either towards the extreme end in terms of both sides. Either it can be too high or it can be too low. So they both are what? They both are outliers that we have to work on. And then here we have missing values. So missing values is something that we have to work on as well. If we have less number of missing values, then it's always a good practice to simply drop these values instead of we can say devoting time to solve their missing value data sets. Then here we have a negative values that we have to focus on. For example, suppose this one was 500 and this one suppose is 550. And here we can, by using the mean average, we can find out the total amount paid as well for any specific data set. And then here we have, suppose here we have the actual amount paid. Suppose here it can be, suppose, let's say 350, and here it can be in terms of 28. All right. So these things have to be visualized here. And then we can define rating. So rating is also inconsistent. So we have to make sure that either the rating should be in ABC format or it should be in the numeric format like we have seen here. All right. So here we can define, let's say it can be 4.2, it can be suppose 3.6, it can be 3.2 that we define, it can be suppose 4 4.9, and can be 3.5 again. So now once we have data processing done, so we have to make sure that we do remove all the outliers, we do remove all the inconsistencies, and also any kind of missing values. So then we have to perform feature engineering. So before we move on to feature engineering, so are we all clear on the concept for data pre-processing? Please give me a quick information, everyone. Perfect. Thank you for confirmation, everyone. So Educa guess, so data inconsistency means, okay, sure. So basically here we have reviews, right? We have ratings. So let's say in some rating we have A, right? Somewhere we have suppose B, suppose somewhere we have suppose C. So is this a consistent format or is this an inconsistent format, Educa guess? This is going to be inconsistent, right? Somewhere we have ABC, somewhere we have in the numerical format. So it has to be either just one. Either it should be ABC in the alphabet format or it should be in the numeric format, correct? We can't have mix and match in terms of this data sets. Negative as depends upon us, our own logic. So if we want to accept negative values, then we can allow that. All else we can keep it to a simple value itself, all right? A simple non-negative values. Perfect. Thank you for confirmation, Educa guest. Next, we have feature engineering. Next, we have feature engineering. Currently, in this given data set, we have total quantity ordered and then we have total amount paid. So can we find out the price per unit from the given data set? In here, in this current data set, we find the question, you can give the answer here. And as you know, here, just a piece of information. That means how exactly this and to be total amount paid divided by the quantity ordered, and here we can find the price per unit, which can be replicated for all the other data sets available here. All right. So this is not available by default, but again, here we have calculated that, and that is what we refer as feature engineering. All right. So, for example, let's say if when we start working on PUBG data sets, for example, in PUBG we have the walk distance, right? And then we have the total, right? And then we have the total, I can say, drive distance. It means suppose how many distance we have traveled on vehicle. So if you want to find out the total distance, if you want to find the distance traveled by a player, so what we have to do, we simply have to add total distance is not available by default. So what we have to do, we simply have to calculate the addition of walk distance, swim distance, and total distance of So we can get it by performing some calculations on the given data set. And that is what we refer as feature engineering. Confirmation, everyone. So we've taken almost enough short break for let's be right back. Continue our discussion on so let me just put on the timer and let's be right back after the break.
Everyone, are we all back from the break? Please give me a quick information so that we can resume. Perfect. Thank you for confirming, everyone. So, after we work on feature engineering, then we have to work on the descriptive analysis, where we had to work on now the descriptive analysis, and we had to work on exploratory data analysis as a part of EDA, as a part of like we can say we use EDA mostly to get insight of the cover of the current data set. Okay, what are the available insights and how we can make use of it as a for our own advantage. So that is what we do as a part of EDA concepts. All right. And again, as a part of our own goal, we have to work on making decisions. Now, first of all, does killing more people increases the chances of winning the game? That is what we are going to find out. And which features were most important while making this prediction? That exactly is what we are going to find out as we proceed further. So we had discussed why exactly we need data preprocessing, so we can scrap data from the because data that we scrap from real world is dirty. That means it has multiple missing values. It contains only the aggregate data. For example, we have sales, we can have multiple missing values as well. It contains multiple errors or outliers. So like we have salary as milestone, which cannot be. And then we have inconsistency in the entire data set, which contains, for example, we have birth dates. Now here, somewhere the birthday can be 10th August 93, and in some place we have in the date format. Somewhere we have rating as 1 to 3, and somewhere we have ABC. And we also have duplicate records. So these are what these are what triggers the need of data preprocessing. All right, as we discussed. And then let's discuss the second myth. It's all about the right algorithm. Yes, algorithm is important, but again, more important than algorithm is data set, right? For example, let's say we are working on building one application. So there are two applications. We have now our main focus is to design one application that should automatically detect if there's a flaw in the given image, then that should automatically detect if there's a flaw in the given image or not, right? So our main use case is to design one application that should detect if there's a flaw in the given image or not. And we have two systems designed for that. We have system A, this application A, which has been trained by, let's say, 10,000 images, by 10,000 images. And then we have application B, which has been trained by 100,000 images. They have almost same algorithm. So that one has been trained by 10,000 image, and the other one has been trained by using 100,000 image. So trained with 100,000 image. So which of these are going? Which of these is going to be much more, I can say, much accurate as compared to the others? So let's say we have two different applications. One has been trained with 10,000 image, and the other one has been trained with 100,000 image. So which one of among these is going to be more accurate? A or B? Absolutely A, absolutely B, right? Because B is the application which has been trained by more number of images, correct? And whenever we are training someone with more number of images, and obviously we are going to get better accuracy, correct, right? And that is the main reason why Google has been undisputed king since last almost 2 decades. Now we know that companies like Apple, Microsoft, Amazon, they don't have any limitations in terms of capital. They have they have good amount of capital, right? They have no hesitation in this in spending more capital on developing the same applications such as Google, right? But again, what Google has that no other company has, Google has the access to enormous amount of data sets, which no other company has, right? So for example, let's say if you talk about Smartphones, and we know that 80% smartphones globally, they all are running on Android, and which is continuously feeding data to Google on almost everything that we do with a device. Google Chrome is having around 60% of market share in terms of all the browsers being used by everyone, again feeding data back to Google. Google search itself is used by more than 90% people globally and feeding data back to Google as well. Then same way, if we want to get directions from point A to B, Google Map is our first preference, feeding data back to Google. Right? For the mailing clients, we know that 80% of different people they still prefer using Gmail as one of the main mail service provider. Again, feeding data back to Google, right? So Google has enormous information on almost every single individual available on the globe. And we have that's why Google has been undisputed king since almost 2 decades now. Because all the other companies, they have a good amount of resources to develop their own algorithms, more efficient algorithm than even Google. But what they don't have is the access to data, and that to that great extent as Google. And that's what has been number one company in terms of data solutions. All right. So that's why we do need to have the access to data to increase the accuracy of the applications. Next, let's talk about the EDA concept as an exploratory data analysis. So analyzing the data to discover patterns, anomalies, or test hypotheses and assumptions with summary statistics and graphical presentations. That is what we mean by EDA, exploratory data analysis. So if we talk about data, data involves everything. Sorted means that we have established relationships between between different data types and among with every single detail. Arranged is when we have a distribution plan. We have been creative and narrative in that. And then we have presented visually. When we present the data visually by using multiple graphs, pictorial representation in terms of graphs, charts, Venn diagrams, and make it more interactive and as interactive as possible. So without the pictorial representation, we won't be able to find the exact meaning or different data sets. All right, and that is what we have to focus on. All right. Now, why we need EDA? So we need EDA to maximize insight into the given data set. We need it to uncover underlying structure and to extract important variables. We need it to detect outliers and all the given anomalies and test the underlying assumptions as well as a part of performing EDA as an exploratory data analysis. So can we say EDA is exploring related data for insights? Yes, Kashyap, we can say that. We can say it's a summary statistics. Yes, Edruka guessed. So now what exactly we try to find out? We have outlier detection. So basically outlier is what? It is simply a value that lies outside most of the other values in a set of data. For example, in the scores 30, 38, 4, 32, 185, 33, 36, 40. Now, here we can see majority of the score is between what? Is between 30 and 40, right? Now, here we have two values towards the extreme end. We have 185 and then we have 4. Now, they both are towards the extreme end, one towards the extreme positive and again extreme towards negative, correct? So in the most possible scenario, we can say that this is what? This is basically outlier. That means they are not going to be true values. And that's what exactly we have to remove. Because if we include these wrong values, and we are simply going to hamper the accuracy of the system, right? Which we definitely do not want. And that is what we achieve here as a part of outlier detection. So are we clear on the concept for outlier detection? Please give me a quick information, everyone. Perfect. Thank you for confirmation, everyone. Can outliers still be useful? Now they're named as outliers because again they are not going to be of any use to us. That's why we have simply work on dropping these values. All right. We can define the okay. Can outlier detection be automated or is it a manual process? Basically, again, we can define the logic as well that can be used for automatically removing all these outliers if they don't fit our logic. We can automate that. Yes, we can do that. All right. So next we have graphs and the histogram. So we use graph bars when we use a bar graph when we have to present data. So where we have one categorical data set and the other one as numerical data sets. So for example, let's say we want to show the population of different cities, then we have the name of cities in on the x-axis, and then we have the numerical value on the y-axis. So when we have this kind of data set that needs to be presented, we have to make use of bar graph. And when we have to present the numerical values both on x-axis and y-axis, and there we make use of histograms. All right. So when we have to represent the numerical values both on the x-axis and y-axis, that's where we have to present that by using these kind of histograms. All right. So histograms for both numerical values on x and y, and we have one numerical value and the other one is categorical value, then we refer them as a bar graph. All right. Then we have the box plot. So let's discuss all the concept of box plot. So what exactly they are. So box plot is basically a combination of 5 different numbers. Box plot is combination of 5 different numbers that we have. Just a moment. Just a moment. So we have multiple outlier values that we are going to focus on. let's first of all focus on what exactly we mean by box plot. Just a moment. So let's talk about. The concept, just a moment. So here we have something called as box plot. We have box plot. So box plot is basically a 5 number summary. So to see a small example, we can take a small 5 number summary to help us in clarifying that. Just a moment. So let's say we have a small summary for we have weight of 10 boxes, weight of 10 boxes. So in terms of weight of 10 boxes, suppose we have the weight as suppose 25, then we had 28, then we had 28 again, then we had 29, then 30, then 34, then we had 35, again 35, 37, and 38. How many numbers we have? Do we have 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we had 10. So now let's say here we are looking to find the box plot of this one. So first of all, we had to find 5 numbers. So here we have to first of all add minimum. The first number is what? Minimum. Second number is maximum. Third thing that we find out is the mean, or you can say we can find out the mean itself. And then we have to find out the first quartile and the or we can say we can find out the median itself. Instead of mean, we can find out median. Just a moment. And then we need to find out the first quartile, and then at last, third quartile. So minimum is weight of now. As you can see, it already has been arranged. So we can see it has been arranged in such a manner we can find out the minimum and the maximum value directly. So the minimum is what? Minimum is 25. The maximum value is what? Maximum is automatically recognizable as 38. And then we have to find out median. So median is what? Median is basically the mean of the mid values. So mid values are what? 30 and 34, correct? So 30 plus 34 and this entire sum divided by 2. By 2, it's going to give us what? 64 by 2 is what? 32 itself. So median is going to be 32. First quartile is basically the mean of the numbers towards left of 32. So the number towards left of 32 is what? 30, 39, 28, 28, and 25. So the mean here is going to be the mid value. This is going to be 28, correct? So first quartile is going to be 28. Just a moment. All right. And then we have to find out the mean of the numbers, median value. So towards the right, what we had 34, 35, 30. So that's how basically when someone person like weight that we have currently in a given scenario. So basically how we can as possible by using these quartiles. For example, someone wants to find out that again how many boxes or okay, what percentage of boxes again they weighed more than 28 kilos. So for example, suppose here we can see 75% of values are more than 20, right? So that is what we can find and directly by using this first quartile. If someone wants to know okay, what is the percentage of boxes that weigh more than 35 kilos? So as you can see here, we have only two values. We can say that again the quartile is going to be more than 28 kilos. That's how it is going to be. All right. So are we clear on the concept of box plot? Please give me a quick confirmation, everyone. If there were 11 boxes, again, then the median would have been the mid value. For example, suppose there was another number, suppose that's 40, right? So what is the middle value now? Middle value is what? 34, right? It's 34, and that would have been the median. Is it clear now? Edrica guessed. If there was 11 values, then again, the median would have been 34. Perfect. Thank you for confirmation, everyone. So same way, when we have started working on the analysis, we also going to work on different scatter plot.
So basically here we are going to work on the perfect correlation, perfect positive correlation. Then we are going to work on highly positive correlation where the change in one value is going to be closely related to the other value. For example, if we have values such as 0, and then here we have 1, here we have 2, same here we have 1 and 2. Suppose if we increase a value by 1 here, then the same increase is also observed in the y-axis as well. If we increase the value to 2, then again same increase is also observed here. Then that is referred as perfect correlation. And then suppose if we increase the value to 1, and suppose if there's an increase, suppose for 0.5 or close to 1, then that is referred as highly positive. If we increase the value to suppose 1, and again if the value increases by just suppose let's say 0.1 or so, then that is going to be configured as a low positive correlation. And then we have no correlation where the impact of one is not going to have the impact on the other. That means even if the value increases, there's no change on the other values. Then that is referred as no correlation at all. And the opposite here is being observed in terms of low, negative, highly negative, and perfect negative correlation. So these are something that we are going to work with when we come back for our session on performing the EDA as a part of a discussion. Now, as a part of the hands-on, so we have to perform different projects. Let me just guide you on what assignments we also have to work on as a part of assignment for today. Just a moment. So for getting the access to assignment, we can navigate to our LMS. And in case we don't have the access to LMS, we can write to support team and they will be giving it to us. So here we can navigate to course content, and within course content, we have the focus on the first module. So here we have assignments. So first of all, we have multiple quiz sections. So in the course section, we have to solve all the quiz sections available here. And then under assignment for day one, we have to come, we can open this up to find the access to the assignment that we have. And as you can see here, as a part of first day assignment, we had to learn more about data science. Then we had to explore the applications of data science. Then we had to learn about random forest from our LMS. Then we had to solve quiz questions from day one from our LMS. And then we had to download and get ready with PUBG datasets. So tomorrow, once we come back, we are going to work on Google Colab. So Colab is basically a notebook. So if you are comfortable working with Colab, we can work with Colab. If you all are comfortable working on your own local Jupyter notebook, then we can work with your local Jupyter notebook as well. Or I'm going to guide you on how we can get started working on Colab by importing this current notebook on which we are going to perform the entire analysis on PUBG dataset. And Educa guys, so again, in case you don't have the access to the data set, so you can get in touch with support team and they will be giving to you the access as soon as possible. All right. And in case you haven't got the workshop, the certification for last weekend, then again, get in touch with support team. They'll be able to help you out. All right. All right. So the email is basically support@edurica.coach. So you can get in touch with them. All right. And tomorrow, once you come back, so here we are going to work on this entire analysis on how we can perform the complete EDA and how we can build multiple models as a part of working on our own analysis on the given PUBG datasets. And we also going to download the entire dataset from the official website available for the official PUBG developer API available for Kaggle. So from Kaggle, we are going to get the access to official dataset. And I'm going to guide you all on how we can get the access and how we can download that to work on a project. All right. All right. So I guess since it is almost time now, so let's say we wrap it up for today, guys. And first of all, again, thank you so much for being a part of this entire session, and especially for being such an interactive audience that you always have been. So again, if you really enjoyed today's session, then please do rate us excellent in the feedback form as a small token of appreciation for the hard work and time that we have put in. And let's meet tomorrow at the same time to continue a discussion on data analysis using PUBG. So again, thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.